In Lesson 4, we're going to be looking at the cosine ratio. Just like in Lesson 3, you are going to be able to label the parts of a triangle as opposite, adjacent, and hypotenuse. And then we're going to use the cosine ratio to find the unknown side lengths as well as angles inside of a right triangle. Now remember from last lesson the acronym SOHCAHTOA. We have so far looked at the first three letters, the SO, and we learned that SO stands for sine of an angle is equal to opposite over hypotenuse. Today we're going to be looking at the second part, which is the CA part, and that is the cosine ratio. Cosine of an angle is equal to adjacent over hypotenuse. Now, since we're considering angle A in this case, remember we can label the parts of the triangle according to angle A, or from the perspective of angle A. In this case, from angle A, the opposite would be side BC, the hypotenuse would be side AB, and that would leave the third side to be right here. This would be the adjacent side. So cosine of angle A is going to be adjacent over hypotenuse, whereas sine was opposite over hypotenuse. And just like with the sine ratio, we have to make sure our calculator is set to degrees. In our first example, we're asked to find the value of x. And what we're given is angle A right here. And we know angle A is 43 degrees. We know that since we're considering angle A, this is the opposite side, and we don't know anything about it. And we also know something about the adjacent side. We know the adjacent side is 15. And what we're asked to solve for is the hypotenuse. So we're going to be using the cosine ratio because cosine uses adjacent and hypotenuse. So cosine of angle A equals adjacent over hypotenuse. So cosine, angle A is 43 degrees, so cosine of 43 degrees is equal to adjacent over hypotenuse. We don't know what that is. Now, there are a couple things we can do. We can first try to figure out what is cos 43 degrees, or we can use some algebra and rearrange this equation and then solve afterwards. I'm going to figure out what cos of 43 degrees is first. So I'm going to type in 43 and hit our cosine button. And you can see with 4 decimal places it's 0.7314. That 3 would round up to a 4 because the next number is a 5. So 0.7314. Cos 43 is 0.7314. And that's equal to 15 divided by x. Now, we want to get the x by itself on one side and all the numbers on the other side. So, first thing we need to do is multiply both sides by x. That way these x's will cancel and we'll have the x on this side. So we have x times 0.7314. That equals 15. And last step, we need to divide both sides by 0.7314. Divide by 0.7314. And we're left with x is equal to, I'm not going to try to do this in my head, so 15 divided by 0.7314. And we get 20.5. So x must be approximately 20.5. Now, it's good that x is longer than this adjacent side because, of course, it's the hypotenuse. And it is a reasonable amount longer as well. In our next example, we're also asked to find the value of x, but our triangle looks different. We're given different numbers to work with. In this case, we don't know anything about angle A, but we know about angle C. So we're going to do everything from the perspective of C. So according to C, we don't know the opposite side. We're asked to find the adjacent side, and we know about the hypotenuse side. So we're going to be using something that uses the adjacent and hypotenuse, and that is our cosine ratio. So cosine of angle C is equal to adjacent, it's the x, we don't know what it is, over hypotenuse, it's the 5. Now our angle C is 53.1 degrees, so cos of 53.1 degrees is equal to x over 5, adjacent over hypotenuse. Now, just like with the last question, I'm going to use my calculator to figure out what is cos of 53.1 degrees first. So 53.1 degrees, cosine of that is 0.6004. 4 decimal places is good enough. Decimal 6004. And that is equal to x divided by 5. Now we want this x by itself, so we're going to multiply both sides by 5 because the x is being divided by 5, so in order to get rid of the 5, we need to multiply by 5. Multiply both sides by 5, these 5's will cancel out, and we will have 5 times 0.6004 is equal to x. So what is 5 times 0.6004? 0.6004 times 5 is equal to, you can see that's very, very, very close to 3, 3.002. I'm going to round that to a 3. So x must be 3. And that answer makes sense. Seeing as the hypotenuse is 5, it's a reasonable answer. In this question, we're asked to find the value of angle C. Now, from the perspective of angle C, which is right here, we don't know anything about the opposite. We know that the adjacent is 18, and we know the hypotenuse is 23. So since we have information on adjacent and hypotenuse, we're going to use our cosine ratio. So cosine of angle C is equal to adjacent, and I'm going to just start writing this in right away, adjacent over hypotenuse. So cosine of angle C is going to be adjacent over hypotenuse, but what is 18 divided by 23? Let's plug that in. 18 divided by 23. And that is this long decimal number. I'm going to use the first 4 digits, 0.7826. 0.7826. And we're in our last step. Now remember when we were working with the sine ratio, when we wanted to actually find out the angle, we used the sine -1 button on the calculator. It's the opposite of using the sine button, is the sine -1 button. So we're going to do the same thing here. Angle C is whatever cos -1 of 0.7826 is. So we're just going to use our calculator, and seeing as I already have the whole number still entered right in here, I'm just going to hit what is cos -1 of that whole number. That way I'm not even rounding at all. And you can see this is 38.49995. This is roughly 38.5 degrees. So angle C must be 38.5 degrees. In our last example here, we are given a word problem. A communications tower has a 100-meter long guy wire anchoring it to the ground. The wire makes a 72-degree angle with the ground. How far from the base of the tower is the wire anchored to the ground? A good way to help us understand this question and know what we need to do would be to draw a diagram. So we're going to start by drawing a diagram. Now here's my tower. Your tower doesn't have to be perfect. And we know that the guy wire is 100 meters long. I'll use a nice gray for my guy wire. And it's anchored somewhere like this. We don't know how high up the tower it's anchored. We just know that this wire is 100 meters long. We also know that the wire makes a 72-degree angle with the ground. So here's our ground, and that's the angle that it's making with the ground. So this must be 72 degrees. And we are asked, how far from the base of the tower is the wire anchored to the ground? Well, we can see that the wire is anchored to the ground right here. And so what we're being asked is, how far from the base of the tower is it being anchored to the ground? If I were to simplify this drawing a little bit, what we really have is just a triangle where we have a 72-degree angle, a 100 length for our hypotenuse, and we are trying to figure out the adjacent for this angle. So we're going to use our cosine ratio. Cosine of our angle is equal to adjacent over hypotenuse. Okay, because this is the adjacent side and this is the hypotenuse for the 72-degree angle. And now we can just solve it like we have been solving all the other problems. So cosine of 72 degrees, 72 cosine. Cosine of 72 degrees is 0.3090. 0.3090. And that's equal to adjacent over hypotenuse. Now we just need to multiply both sides by 100 in order to eliminate the 100 from that side. And we are left with 100 times this number. We're just going to move the decimal twice to the right. 30.9. So we know that the guy wire is attached. Can't even remember how to spell attached. Is anchored to the ground 30.9 meters from the base of the tower. So in summary, for any right-angled triangle, if you are given a certain angle to consider, the sides can always be labeled as opposite, adjacent, and hypotenuse. Our cosine ratio, the SOHCAH, the second part in SOHCAHTOA, the cosine ratio is equal to adjacent over hypotenuse, and we can use our cosine ratio to find either a side length or an angle in a right-angled triangle. Remember to set your calculator to degrees. We use the cosine button to find the ratio, that decimal number, and we use the cos -1 button to find an angle.